Hey guys, so let's look at the last two types of identities we're going to deal with, double angle and half angle. So here's our double angle identities. Yeah, I gave you your formula sheet over here. So double angles right here, half angles right here. That's what we're going to be dealing with. So same concept as the sum of difference identities. We're going to use that unit circle and figure out exact values of trig functions. So we know sine of theta is 5/13 and it tells us to find cosine of 2 theta. Now pay close attention to where we are located. It says 0 is less than theta is less than pi over 2. Take a look at your unit circle. Somewhere. There. So 0 to pi over 2. That's the first quadrant we're looking at. So first quadrant, this is how your triangle should look. That's my theta. We know sine of theta is 5/13. Pythagorean triple or Pythagorean theorem, however you want to look at it, this has got to be a 12. 5, 12, 13 right triangle, or take your calculator. 13 squared minus 5 squared. Square root of that answer, you get 12. So let's see what our identity is for cosine of 2 theta. So over here, cosine of 2 theta. We got a few options. So actually we didn't need this triangle in this particular case because we have all these different options. We could just use this one right here that only deals with the sine. In fact, I think that's what we're going to do. But again, there's many ways to do these guys. You can use any one of these three identities for cosine of 2 theta. Sometimes one will be easier than another. It's a good habit, though. Just go ahead and draw your triangle in case you need one of those other trig functions. So cosine of 2 theta is 1 minus 2 times sine squared theta. Easy. Plug it in. So cosine of 2 theta is going to equal 1 minus 2 times sine of theta is 5/13. And we got to square that. All you got to do is type that in the calculator and call it a day. Okay, hang on. Let me reorganize this thing. Now, 1 minus 2 times 5/13 squared equals 119 over 169. Sure, why not? That's our answer. Moving on along. Let's check out the next one. This time we're looking for tangent of 2 theta. Let's see what our options are on this one. So tangent 2 theta, for tangent we only have one option. For sine we only have one option. Cosine's the one that has a bunch of different options to choose from. So let me go ahead and grab that and make my triangle. All right, so here's my identity I'm going to use in a moment. Let's see what quadrant we're in. We're from pi to 3 pi over 2. So if you remember, 0, pi over 2, pi, 3 pi over 2. This is quadrant number 3. And you can, of course, look at your unit circle to see that. 0, pi over 2, pi, 3 pi over 2. So we're in this quadrant here. That means our x is negative and our y is negative. Okay. So we're drawing this triangle in quadrant 3. So we gotta go to the left, we gotta go down. Terrible triangle. Yeah, good enough. That's our right angle. That's my theta. Pretend I don't have terrible drawing skills. So -7 over 25. It's cosine, so that's adjacent over hypotenuse. Now, this is not one I recognize as a special Pythagorean triple, but it probably is. Let's find out. Use the calculator. 25 squared minus 7 squared. So it's 576. Square root of that is 24. So yeah, there's another Pythagorean triple for you. That's not one of the two most common ones, so I didn't recognize it, but it's there. However, we're in the third quadrant. That's got to be a -24. If you think about it, whenever we take a square root, we can do plus or minus, right? Usually, whenever we're dealing with Pythagorean theorem, we're like, oh, we just take the positive because the side of a triangle can't be negative. But we're not exactly dealing with a normal triangle here. We're dealing with the whole unit circle. So it can be a negative side of the triangle. In this case, it is. So now what is tangent? Tangent is opposite over adjacent. So that's 24 over 7. So let's see, tangent theta is 24 over 7. Like, what about the negatives? Well, it's negative over negative. They cancel out. We have positive 24 over 7. You can type it in the calculator if you don't believe me. So now I just plug in the numbers. Tangent of 2 theta is equal to 2 times 24 over 7 over 1 minus 24 over 7 squared. Just type that in the calculator. No need to do all the arithmetic by hand. 2 times 24 over 7 over 1 minus, I'm going to use parentheses, 24 over 7 squared. And that gives you negative 336 over 527. Okay. So you might be wondering, well, why was tangent 2 theta negative, but tangent theta was positive? Let's think about that for a second. Let's look at our unit circle. So I was in the third quadrant. So my angle was between, we can use degrees, 180 and 270, right? So if I double that, we're doubling where we could be at. So we could be anywhere from 360 to 540. So it could be pretty much anywhere in here. So that's why it's possible for your double your angle to be a negative, because it doesn't mean you're in the same quadrant. You could be in any one of these quadrants. Just because your tangent of your angle is positive doesn't mean tangent of twice your angle will be. Let's think of a simple example. If we have 60 and I double 60, tangent is definitely going to be negative. Remember, it's all seniors turn crazy. So the tangent's positive in the first and the third quadrants. So if you just so happen to land in either the second or fourth quadrant, whenever you double it, tangent's going to be negative. So don't let those signs fool you. So here we're in quadrant number 2. We're looking for cosine of 2 theta. Now, if I look, none of my identities deal with tangent here. So let me go ahead and draw my triangle and try and figure out what to do. Again, you can use any one of these 3 identities you so choose. Let's just see what happens. So, quadrant 2, not 1. Theta. So tangent is opposite over adjacent. One of those is negative. See, it's a negative, so either the top or the bottom is negative. We don't know which one, but we do know which one because it's in quadrant 2. Quadrant 2, x is negative. That's negative 21. Now just stick with the 20. Just pay attention to which quadrant you're in so you'll know which of your values is negative. Now let's see if this is a Pythagorean triple. I don't know. 20 squared plus, I guess you can go ahead and throw that negative in there. It doesn't make a difference as long as you use your parentheses. Is 841, and the square root of that is 29. Okay, another one. There's many different Pythagorean triples, infinitely many in fact, but yeah, there's only 2 real common ones that you'll see. And these are not there. So use Pythagorean theorem, figure out what your other side is, and you're good to go. All right, so I know what sine is. I know what cosine is. I guess either one of these will do. Eeny, meeny, miny, moe. I'll take this one this time. Okay, if we look at this, 2 times cosine of theta squared minus 1. So we need cosine of theta, negative 21 over 29. Cosine of 2 theta, 2 times that fraction, squared minus 1. Type it in. (41 over 841). Okay, keep on going. So now let's look at these half-angle identities. What's really interesting about the half-angle identities is all of them are dealing with square roots, and you got plus or minus. So you're going to have to think about which quadrant you're in. Okay, so you got to think very carefully about which quadrant you're going to be in whenever you're doing the half-angle formulas. Also, yes, it is possible to have a square root under a square root. I mean, think about it. If you're trying to find sine of, let's say, half of 45. Well, we know 45 is square root of 2 over 2, so if you plug that in here, you're going to have 1 minus square root of 2 over 2. Simplify that, and you're going to have a square root with a square root underneath it. That's perfectly fine. That's applying. Okay. Cosine's negative 4/5. We need sine of theta over 2. Let's see what our formula is. So for all of these, the only trig function we need is cosine. This one gives us cosine, so we don't have to find anything extra. Let's first figure out, are we going to do a plus or are we going to do a minus? So let's see. Theta is somewhere between pi over 2 and pi. Half of theta, that means take half of everything. What's due to one side, due to all of them. So if I divide everything by 2 here, then pi over 4 is less than half of theta, which is less than pi over 2. So what quadrant is this in? Let's go look at our unit circle. Let's see, it's from pi over 4 to pi over 2, so that's from pi over 4 to pi over 2. So it's somewhere in here. So it's somewhere between 45 and 90. So not only do you know which quadrant it's in, but you know it's in this upper half of the first quadrant. That doesn't matter because in the first quadrant anywhere, it's going to be a positive. So we know we have positive. In fact, I'm going to emphasize that. Positive square root of 1 minus cosine theta over 2. No, you wouldn't only draw the plus sign, but I want to make sure you see this is positive because right here. We're in quadrant 1. Let's make them smaller. So we know we're in that theta over 2 is in quadrant 1, so that means not half of theta must be positive, but sine of half of, I guess we should say. The sine of theta over 2 has to be positive because theta over 2 is in quadrant 1. Okay, let's plug it in now. That's going to be the square root 1 minus negative 4/5 over 2. So I'm not sure if the calculator will simplify this nicely or if we'll have to do it by hand. Let's find out. We should get a nice radical. Or simplify, let's see. Yep, 3 squared to 10 over 10. Cool. So 3, I forgot already, square root of 10 over 10. That's what sine of theta over 2 is. That's it. That's all there is to it. All right. Tangent theta is equal to 2 square roots of 6. And theta is in the first quadrant, so obviously half of theta is in the first quadrant, right? If we divide all those by 2, we get 0 less than theta over 2 less than pi over 4. So theta over 2 is in quadrant 1. So we're going to be dealing with positive. Cosine of theta over 2. Let's see. Almost the same formula as sine. Has a plus sign here instead of a minus sign. This time we weren't given cosine of theta, we were given tangent of theta. So to find it, we're going to need to draw a triangle. It's in quadrant 1. So this, we draw the triangle for theta, not for theta over 2. So draw the quadrant 1 triangle. Yes, theta is in quadrant 1. Opposite over hypotenuse. So this is how I'm going to write it out. I put it over 1 because, well, I need a fraction for my triangle. So let's see, using the Pythagorean theorem, what am I doing? That's tangent. Tangent's opposite over adjacent. Sorry. Okay, glad I caught that before we went any further. My bad. So 1 squared plus 2, well, these 2 square roots of 6 squared is whatever the heck this is, 25. Oh, so we know the square root of that is 5. That'll be 5. So cosine of theta, well, that's easy enough. 1 over 5. So cosine of theta over 2 is going to equal positive, I'm not going to write the plus sign this time, 1 plus 1/5 over 2 squared that. I have to then calculator, let's see what happens. Square root of a fraction, 1 plus 1/5 over 2. Square root of 15 over 5. And I'm not going to make you do all of that algebra. Sorry, not algebra, arithmetic to simplify that. Make sure you show me how you got your cosine of theta. Make sure you show me you plugging it in. Then you can give me the answer. That'll be good enough for me. Let's see. Okay, where are we at for this one? Tangent of theta over 2. Let's grab that formula. Okay, cut everything in half. Let's see where we're at. So we're between pi over 2 and 3 pi over 4. Oops. I got to say the sign. We're somewhere in here. Let's find out whether that's going to be a positive or a negative for tangent. Pi over 2, 3 pi over 4. Okay, where are we at? Where are we at? Pi over 2, 3 pi over 4. All seniors turn crazy. So, yep, tangent's going to be negative in this one. But you can also look here. We got a negative over a positive, or a positive over a negative, really. So, yeah, definitely going to have a negative for our tangent. So it's going to be tangent of theta over 2 equals negative square root 1 minus, and let's figure out what cosine of theta is. Here's my triangle. The theta is in which quadrant? So theta is in between pi and 3 pi over 2. The theta is in the third quadrant. So we draw the triangle for theta. Not for theta over 2. Theta over 2, that's in quadrant number 2. Theta is in quadrant number 3. So let's draw a quadrant 3 triangle. (17) hypotenuse, 8 is my opposite. Hypotenuse is not negative, that's negative, and whatever the heck this is going to be negative. Let's find out what the heck it is. 17 squared minus negative 8, if you wish, squared. Obviously, you could just do the same as 8 squared. And then we square root that to get 15. So cosine of theta is going to be negative 15 over 17. There, you can just type in the calculator. Negative square root fraction 1 minus negative 15/17 over 1 plus negative 15/17. Oh wow, -4. Okay. So yes, this looks terrible and crazy, but it's a nice little -4. Okay. sure. What's next? I think I'm going to separate. Yeah. So I think I'm going to separate the video here. We have plenty of time, but this way we can just pick which video. This one's just going to be for applying the theorems, and this is going to be for proving with the theorems. So see you in a minute.